How Science Works is a part of the GCSE science curriculum. To support this initiative, Teachers TV is showing 3 programmes showcasing the work of 3 very different scientists. There are also substantial support materials on the internet. These web resources have been developed by Sheffield Hallam and York universities. At King Edward School in Sheffield, teachers tried out 2 programmes and their related activities with their Year 10 students. In this lesson, teacher Will Davey and his colleague Simon Cook used the Engineering Gold programme as a warm-up to the students carrying out an experiment of their own. The programme shows Professor Peter Starring's research into developing a self-lubricating ski.
Professor Starring's film gives us a really great context for looking at data, and the activity where students test out their own lubricants is very useful because it gives them first-hand experience of how difficult it actually is to get reliable data.
The nature of this morning's investigation is going to be to try and investigate the ways in which we can make skis go faster. We're going to begin by showing you a DVD of a scientist. He's a very local scientist, I'm proud to say. In fact, his work takes place just down at Sheffield University. There's a lot of information, and all of it is absolutely relevant to what you're going to be doing after.
As you can see, it's now starting to move just a little bit more.
But this isn't just an opportunity to sit back and relax.
Just going to pause that briefly and explain what the results are showing.
When the teacher showed students the film, he paused it at several points. One of those points was when the graphs came up. And that's really crucial because they show some very significant results.
What I think we ought to do next is, could you come just bring your stools out so you can see the front bench? As you can see...
Having seen the programme, the class will try out Professor Starring's experiment.
It's similar. This is a ski.
The equipment might be a little more basic, but the intention is the same.
As long as we use the same tile each time.
In the setup, the teacher also explained the parallels between what the students were doing and what Peter was doing, so it made the whole process feel more real.
We're expecting you to have possibly 5 formulations cunningly labelled A to E. You're going to decide on what those formulations are going to be. We want you now, in the next hour, hour and a half, to arrive at a position where you have come up with a formulation that you would be able to recommend.
Well, the teacher set the activity up in quite an open way. So the students were given some structure, but he actually gave them some time to do some preliminary work to start with. And he gave them permission, almost, to not know quite what they were going to do. So they felt as though they could use some of their time to play with the equipment. So they felt comfortable that they weren't expected to know immediately how to carry out their inquiry.
Being given an open activity allows the students to ask, what if? Some have the novel idea of testing the setup without any liquids as a starting point.
What was your control? What would you mean by control?
Well, we didn't have anything on the board, so
okay.
we were just doing a test.
So without lubrication?
Yeah.
And what height did that start sliding at?
We did 2 tests, so we've got 10.5 centimetres with it.
Okay, great. So, okay, do your 3rd one then, and then you can get an average result.
The way in which the teacher set up the inquiry, he emphasised to students that they should feel free to do some trialling, some preliminary work. Now, this is not new to the National Curriculum for Science. It has been in the curriculum before.
4 parts water, 1 part detergent has been more effective than 4 parts oil, 1 part detergent. An equal balance of oil and water with some detergent to hold them together, and more oil than water. So it looks as though water is more effective than oil for lubrication. I was expecting the oil because you generally associate oil with slipperiness, and we use oil in cars to keep things fluid and lubricated.
They're thinking about the experiment critically as they're doing it because it is their experiment, and they feel as though they have the right to change it, if you like, as opposed to being given an experimental method.
At the beginning, it was a bit low at the start, so we got 15.5. So we questioned that. Yeah. So then we started to put the lubricant on, and it got higher to like 31.3. So we did no substance again, and it went to 22 centimetres. So we're wondering, so we did a double attempt there.
But we think that was because there was already substance that we couldn't wash off on the book.
It's all very well setting up open activities and encouraging pupils to take ownership of their research, but in most classrooms, time can be an issue.
I think teachers are sometimes put off by open-ended investigations because they think it's going to take a lot of time. The key is to plan so that the introduction and the follow-up are quite tightly structured, and the time is given to the most important part of the enquiry, which is where students are developing their own ideas.
Another concern might be that an open activity could leave less able students floundering.
It's always a balance, though, between making them feel confident that they're supported enough and have enough structure to be able to push themselves that little bit further, and leaving them enough space to develop their own ideas. So all of the activities that are associated with the films come differentiated.
And when the students are supported and confident, they deal better with unexpected results.
It doesn't move because it's stuck, so it's an unfair, it's an outlier really.
Maybe if we use less, it's more likely to slide.
Is there another programme which is the best sticking? Because we'd be really good at that.
Students are often looking for a yes or no, black and white answer. And one of the things that their own inquiry work enables them to appreciate is that just because their lubricant didn't seem to work didn't mean that they had a bad experiment.
This lesson's been quite good, I think. It's been quite fun. We got quite slippy and quite messy, which is always nice. We've had a lot of control today over what we do, whereas often in practicals they kind of tell us exactly how to do it. So it's been a good one today.
In another Year 10 class, these students are carrying out a role-play activity relating to the film Chasing the Wind.
We'll have a video clip from the DVD. That's going to be looking at a woman called Maggie. She is working on satellite technology, and what she's focusing on is how the wind direction and speed and so on at different levels of the atmosphere is changing over time.
The temperature does seem to be going up. Temperature is something that has been monitored over a number of years, probably over at least 100 years, probably longer than that. And so that is a sort of a clear indicator that something's happening.
For role play to be effective in the classroom, we need to go through the 5 phases of preparation, briefing, action, debriefing and follow-up. We must go through all of those phases, and we must ensure that each phase is addressed effectively.
For the first part of their briefing, students use the internet to help write their presentations. But they're going to be grilled by other students, so they need to be convincing in their role. Teacher Matt Galvin runs through some of the pitfalls that they may face.
Teams 3 and 4 are going to be arguing against you, and they're going to try and catch you out with difficult questions. What sort of questions do you think they might ask you?
Imagine that they're going to try and argue that it's the natural sequence of the Earth that is causing climate change rather than like mankind's effect. But so they'll probably try and denounce us like that about it.
Basically, they're going to be like asking, "Oh, isn't climate change going to kill more people than it helps, or isn't it going to destroy environments?" That kind of thing. But we've got a strategy. We've thought about what they're going to ask us, and we've prepared answers to everything. So we think we've covered ourselves.
What angles are they going to go for? How are they going to try and catch you out?
Probably the proof side of it, because obviously science is not a definite thing, it's more theories, and although there is proof, we can't say for definite that this is causing it, so they'll probably go with that.
If I could ask the team of presenters and question answers to come up, if I could have team 1 and 2 here.
Having done their research and watched the stimulus video, it's time for the main event. One person from each group will present their viewpoint, in role of course.
We're Human Footprint, and we believe it is humans that have had a climate-changing effect on our environment. We're going to show you why.
Belief in global warming is nowadays almost universal. However, there is another belief that it is a bad thing, and this is wrong.
And it's not just those who are presenting who have to be on their toes.
The other thing the students have to do is that those who are not going to present have to be prepared to be a member of the audience, an active member of the audience who will ask questions.
Fantastic, well done. All 4 cases argued very strongly, and now it's your turn.
To prevent the question session being met with a deathly hush or being dominated by the more confident students, all pupils are invited to write down questions and give a copy to the teacher.
Do you have any proof that temperatures will actually rise by as much as 6 degrees in the next 50 to 100 years, as you said, and as is commercially believed? Is this not just a media myth?
In our presentation, we didn't actually state that, but I can tell you that there is proof that global warming is occurring. There is, we're burning gases, we're burning fuels that are releasing harmful gases. And yes, the media might want to exaggerate things to get the message across to people, because people do need to know about global warming as it is a serious issue.
Over the last 100 years, the human population has increased dramatically. More humans means more cars, which has obviously had a massive increase in the carbon levels. More carbon gases traps more heat in. How can you not say that this is our fault?
Well, because if you look at how much carbon dioxide we're producing compared to how much, say, the ocean or dead plants, animals are producing, it's completely tiny in comparison.
You then must debrief, and that will come in 2 forms. One is debriefing what has happened during the action. The second is giving the youngsters an opportunity to come out of role and to think about the issues personally.
I think that over the past 100 years that natural disasters have been on the increase, and we should do everything to try and stop it, to reduce carbon dioxide emissions.
The media are portraying it in a light that's not true. So I reckon it's not true, and I'm not saying you're bad people. I'm just saying that if it makes good stories and people buy it, so you're doing it for a reason. So it's not necessarily true.
Students find this approach very, very motivating. They really do enjoy and find it so stimulating, mainly because of the ownership. They're developing their presentations, they're engaged in the debate, and they really do respond very positively.
How many of you think climate change is man-made? So that's about half or so, maybe just over half. That's interesting. How many of you think we should be reducing our carbon emissions? Wow. So that's everyone bar Jonathan, I think. I thought it was fantastic. I thought the kids really raised their game for the debate. They came up with some great answers, and they all seemed to walk out with a big smile on their face. So, yeah, I enjoyed it greatly. I was really proud of them, and I think they seemed to enjoy it as well.
You can find these programmes and their associated curriculum materials on the Teachers TV website, teachers.tv/science.